Hello everyone. This is the Dr. Sasikumar, Professor, Department of Computer Science and Engineering from RMDEC College. Today we are going to discuss about the cache memory mapping technique. So far I have completed, I have given two videos. In that two videos, I have explained direct mapping technique and another one is the set associative mapping technique. And in this video, I'm going to tell about the fully associative cache memory mapping technique. The same example I have to take that assume there are three small caches, each consisting of four one-word block. One cache is fully associative, second is a two-way set associative, and the third is a direct mapped. And we have to find the number of misses and fit for each organization given the following sequence of block address and draw the necessary diagram for each cache organization. So this is a fully associative cache memory mapping technique. What is a fully associative method? Totally, as per the given example, we have totally four cache block. Every block which contains only single set, and any memory block can be stored in any cache block. Right ahead here, there is no mathematical formula. Right, wherever the memory location is memory block is available, then we can store the block address in that the respective memory block. So the fully associative, we need to find out the how many number of pieces and hit factor. So this is there is no mathematical formula. So you can store the data in that any memory, free memory location. That is an advantage, but we need to we need to implement the searching technique. That is one drawback. But the data can be retained for a longer period of time. That is an advantage of a fully associative. So as per the example, we have totally 9 block address. So 32, initially the 32 is not available. So hit occur and sorry. Uh, Initially the 32 is not available. So miss occur. And where we store the data means what? At 32, totally there are 4 blocks available. So the block 0 is now free. So you can store 32 block address in that cache block address 0 and the memory block address is 64. The memory block address 64 is not available in the cache memory block address. So miss that cache. And in block 0, we have a memory of 32 and the remaining three blocks are free. So you can store that memory of 64 in that block 1 of cache address. Then again, now you take that the memory block address is 32, but it is already available in that block 0 of cache memory block address. So hit that there. And the block 0, we have a memory of 32, and block 1, we have memory of 64. Now you can fetch the memory address 64. Yes, it is already available in that cache memory address. So hit occur and block 0, we have a memory of 32, and block 1, we have a memory of 64. And now the another address from memory is 8. It is not available in that cache memory address. So miss that cache. And the block 0 which contains the 32 and block 1 which contains the 64. So block 2 is free now. So 8 is stored into block 2. And the number 5 from main memory address, it is not available in the cache memory address. So miss that cache. The block 0 which contains the 32, block 1 which contains 64, and block 2 which contains 8. Then last the block 3 which contains what? Memory 5. So now all four blocks are filled up. And again, you refer the memory address is 8. So 8 means it is available in the cache address. So in block 2, we have a memory address 8 here. So this is hit and that there is no changes in that existing block address. Now 26. So 26 is not available. So where we store that 26 means what? In that which one is least recently used means what? 32 is least recently used. So instead of 32, you can store memory 26 and block 1 we have a 64 memory address. Block 2 we have a 8 memory address. Block 3 we have a memory address number 5. So 8 again. Yes, it is available in that block 2. So hit occur and in block 0 we have memory 26 and block 1 we have memory of 64 and block 2 we have memory of 8 and block 3 we have memory of 5. So out of 9 address, so totally 4 hits occur and 5 misses occur. So I hope you understand that fully associative cache memory mapping technique. Thank you.